Okay, so here I've got another Part C exam type question. It says find the area of triangle ADE, that's this triangle right down here, ADE, round your answer to the nearest square centimeter. So what this question is asking me to do is work my way through this complex shape. It's a complex shape because I've got 1, 2, 3 different triangles that I could work with. And it's asking me to work my way from the top of the shape all the way to the bottom and then find the area at the bottom. There's a couple of things that tell me that I'm not ready to just start in triangle 3 here. First of all, I do know 2 things about it, but since this is a non-right triangle, I don't have enough to use sine law. So the first thing I'm going to have to do is work my way through triangle 1 into triangle 2 and then end with triangle 3. Now there's a couple of things I have to notice. First of all, there's a shared side here between triangles 1 and 2, and there's another shared side here between triangles 2 and 3. Those are going to be important because as I figure out those measurements, I can kind of transfer them down into the next triangle and work my way around. So there's a few different things I have to remember here. First of all, I'm going to start up in triangle 1 to find this side length. Then I'm going to work in triangle 2 and triangle 3. I've got to realize that I've got 2 right triangles and a non-right triangle. So I'm going to be doing SOHCAHTOA, SOHCAHTOA, and then sine law for any angles and measurements that I need. And then when it comes time to find the area, I can do either Hero's formula or the Trig formula. I'll decide when I get there. So the first thing to do is going to be to redraw this first triangle with the measurements that are there. This is a 30-degree angle. This side measures 12.5. Here's the right angle, and what I'm looking for is side X. So between SO, CA, and TOA, I need to choose the one that works with these 2 sides. So first I have to label the triangle. Across from the 90-degree angle is my hypotenuse. Across from the angle I'm working with is my opposite side, and the third side is called adjacent. So the one that works with opposite and adjacent, because I have opposite and I want adjacent, is TOA. So it's going to look like this. Tan of 30 is equal to opposite, 12.5, over adjacent, which is x. Now to solve for x, I'm going to set up equivalent fractions and cross multiply to get my answer. So on the calculator, it looks like this. 1 times 12.5 divided by tan 30. I always multiply the diagonals and divide by the other value. So 1 times 12.5 divided by tan 30, and that gives 21.6506. I'm always going to round to the 4th decimal place until my final answer. That's a safe bet when you're doing a final exam, is to leave that many decimal places and then only at the very end round to the place they're looking for. So here I'm going to make x equal to 21.6506. Beside that 6, there's the 4th place after the decimal. Beside that is less than 5, so I don't have to change that 6 to a 7. So now I'm going to work in triangle 2, and before I do that, I'm going to redraw it. There's the right angle. This is given 55 degrees, and this 21.6506 is what I just found. That will be the shared side between triangles 1 and 2. So in triangle 2, notice it's the hypotenuse, 21.6506. And the one I'm looking for now, I'll call this side y, is the shared side, this one, between triangles 2 and 3. So again, I'm going to label my triangle for SOHCAHTOA. Across from the right angle is hypotenuse. Across from the angle I'm working with is opposite, and the third side is called adjacent. So out of SO, CA, and TOA, I want the one that uses hypotenuse and adjacent. That's A and H. It's right here in CA. So that's going to be the cos of 55 is equal to adjacent y divided by hypotenuse 21.6506. Now remember, I just used y because x was used to find the side of the other triangle, so I'll use y this time to not confuse myself or the person correcting the question. So now I'll cross multiply to solve for y. I'll multiply my diagonals and divide by the other number. So here I get cos 55 times 21.6506 divided by 1 equals 12.418, and then that 2, that's the 4th place after the decimal, that 2 is going to round to a 3 because the digit beside it is 5 or above. If this number, which it is 5 or above, that means this one's got to round up by 1 digit. So y is equal to 12.4183. And that represents the measurement right here, 12.4183. Now that I'm ready to work in triangle 3, I'm going to redraw it, where I've got some space over here. And that measurement is 48 degrees, that's given. This is 14 centimeters, given in the question. This is 12.4183. That's what I just found. It's the side that's shared between triangle 2 and triangle 3. Now let me just point out here, this question mark shouldn't be here. That's from another form of this question, so let's ignore that. So what I need to find is the area of this triangle. They called it triangle ADE. I'm going to relabel it, and you can do this anytime you want. I'm going to relabel it ABC, and the reason for that is because my sign law uses A, B, and C on the corners, and lowercase a, b, and c on the side lengths. So that's going to be easier for me to work with. So across from angle A is side length A, across from angle B, side length B, and across from angle C would be side length C. Now what I really need to know here eventually is angle C, because I remember that the area of a triangle can be calculated as any two sides, here it would be sides A and B, multiplied together times the sine of that angle between them, all divided by 2. But first I'm going to have to do some sine law to find those missing measurements. So A over sin A equals B over sin B equals C over sin C. Now the only thing I'm going to be able to find here, I'm going to have my B fraction, and I've got one number from A. I don't know anything about the C's. So what I'll find first is angle A right up there. And then I'll be able to subtract 180 minus 48 minus that angle to get angle C. So let me fill in what I know. Little a is 14 divided by the sin of angle A, which is unknown. Lowercase b is 12.4183 divided by the sin of angle B, which is 48. Now my C's, I can write them, but I don't know anything about them, nor do I need them. So I'm going to ignore that fraction. And now to solve, I'm going to cross multiply. Cross multiplying here, 14 times sin 48, because they're diagonal to each other, divided by 12.4183. 14 times sin 48 divided by 12.4183 gives me 0.837798052. That number is not important because what that gives me is the sin of angle A. I don't need to show this next step, but what I need to remember is that I have to take the shift sin. Your calculator might have second function there, mine's called shift, so I can get that sin minus 1 ratio. That gets rid of the sin in front of angle A. And when I press equals, it's going to give me with something way more logical than 0.83 as an angle. So equals 56.9083 degrees is angle A. Now to figure out what angle C is, I'm going to have to do 180 minus 48, because that's one angle, minus 56.9083, because that's the measure of the other angle up here, and that'll leave me with what's left, and that's angle C. So 180 minus 48 minus 56.9083 leaves 75.0917. So this is the measurement for the angle right there. And now that I have this angle and the two sides that meet at that angle, I can find my area. So area is A times B times the sine of C divided by 2. And when I fill that in, it looks like this. A is 14 times B, which is 12.4183, times the sine of angle C, which is 75.0917, all divided by 2. So let's see that on the calculator. 14 times 12.4183 times the sin of 75.0917 divided by 2. And I don't have to press equals in between all those multiplications in my division, because remember, in the order of operations, multiplying and dividing can all happen at the same time. So here I just need to press equals, and I get an area of 84.00 square centimeters. And obviously I look one place to the right to round it, so my final answer, area of triangle ADE, is equal to 84 square centimeters. That's rounded to the nearest unit. And that's the final answer.